Good morning, dear student. My name is Adaikalaraj, working as an assistant professor in St. Joseph College of Arts and Science, Kadalur, in the BCA department. In this session, we are going to see how to check whether the given number is a prime number or not. In the previous section, we have done a program to check whether the given number is prime number or not. This number is going to be simply a different type of program. That is, we are going to minimize the execution time by reducing the number of iterations. So let us see how. In the previous program, we were dividing the number, that is, if consider 7, if 7 is going to be a number, we start the division from 2 and ended this execution at n minus 1. Since here in this case num equal to 7, so I start this execution from 2 and end up with 6. So this is the actual program. Each time 7 will be divisible by 2, 3, 4, 5 and 6. If there exists a remainder, then this 7 is said to be a prime number. What happens here? We can see it here pictorially. There exists a remainder. Actually, there exists a remainder. Here I got a remainder 1. Here also 1. Here I got a remainder 3. Here I got a remainder 2. And here I got a remainder 1. So always there exists a remainder. So this number is a prime number. In case of 6, what happens? I am going to start with 2 and end up with 5. The similar thing has to happen. Then only we can say it is a prime number. But here it is reciprocal. When I am dividing this number by 2, I get a remainder 0. When I am dividing by 3, it gives a remainder 0. When I am dividing by 4, it gives me a remainder 1. When I am dividing by 5, it gives me a remainder 1. So what happens here? I am getting a remainder 0. If I am getting a remainder 0 in any one of the case, then it is not said to be a prime number. So this is the thing which we have done. We start with 2 and ends with 5. That is in case of 6. That is, we start with 2 and end up with num minus 1. That num minus 1 is 5. So num equal to 6, num minus 1 is 5. So you should be very clear in this. What I am trying to say in this program, in the upcoming program, is instead of dividing that number up to num minus 1, it is more than enough to divide that number up to num by 2. That is, we have to start up with 2 and end with num minus 2. It is more than enough to find whether the given number is prime or not. So what I am trying to say is, if num equal to 6, instead of dividing that num from 2 to 5, it is more than enough. For example, consider it is more than enough here to divide that particular number from 2 to 5. What happens? 5 divided by 2. What happens? 5 divided by 2, I get a remainder. I get a quotient 2. That is, it is more than enough to divide a number from 2 to 2. That is 2. That is, divide a number by 2 to 2. That is, so this is something. So sorry. What happens if I am going to divide a number from 6, that is n num equal to 6, when num equals num divided by 2, 6 divided by 2 is 3, that is 2 to 3. It is more than enough. So consider if number equal to 7, it is more than enough to start from 2 and end up with 3. That is 7 divided by 2, I get a quotient 3. Whenever I divide a number 7 by 2, that is equal to 3. So ending iteration, that is equal to the ending iteration 3. So this 3 I am giving here. I am going to start up with 3. So what if I am going to find whether a given number 230, so let's consider 231 is a given number. If I am going to find whether this 231 is a prime or not, I have to divide this number from 2 to 230, right? So 2 to n minus 1, that is 230. It has more iteration. So what I am trying to say is, we can start from 2, that is num equal to 231. So 231 divided by 2. So what is the quotient here? So quotient equal to 115. I can start from 2 and 115 and end up with 115. The number of iteration, so in the first case I am going to start from 2 to 230, that is I am going to start from number 2 to 230. That is how many iteration? It will proceed along 228 iteration. But in this case, or number of iteration is considerably reduced. That is starting from 2 to 215, that is 113 iteration. So this is how I have simplified the program, and I have similarly written a program for that particular logic. So this is the actual program I have written. See what happens. Instead of this is the only area which I have changed. You have to notice it clearly. Other than this, all the programs, what all the codings what you see here is already present in the previous prime number program, prime 1. So what happens here, instead of writing like this, in the previous program I have written like this: I less than n. Instead of writing like this, I have given I less than or equal to n minus 1. Let us see whether it provides the same result as the previous program. Control F9. I am executing this program and I am going to give 6. I already know that 6 is not a prime number. See, 6 is not a prime number. I am going to give 7. The result must be 7, which is a prime number. The given number 7 is prime. So this is how I reduced the number of iteration. Thank you students for watching this session.